So again, welcome to tonight's CNC tips and techniques. Tonight, we're going to do a follow-up from last week's meeting where we talked about the cutting board projects. Tonight, we're going to take a look at setting up the toolpath for that, especially the V-carving toolpath. That's what we're going to look at in particular tonight. So with that, let's go ahead and hop over to the V-carve demo. Okay, so this was the project that we designed last week, and I want to go over some things on the toolpath. Now, most of the toolpaths are using the V bit, all the design stuff, although we do have a cutter bit, straight bit cutting out the outside. I'm going to start by talking about the V carving on this, and for that, I've set up these two toolpaths right here. And these are included in the file that came with it. Now, somebody mentioned at the beginning that they didn't find the file. I'll definitely include a link for that file in the email that I send out tomorrow. So you'll have that. It is also on the Next Wave website. If you go to the project tab on the Next Wave website, you'll also see this project listed out there as well. And if after you get the email, you still have trouble downloading or getting it, drop me another email. We'll get it to you somehow. Okay, so for this setup, we designed these, what I call simulated chip carving. Now, one of the things that I do when I make when I make a design like this, I like to make sure that none of the areas are so large as to either cut through the project or to require a flat bottom. And that's just a little requirement I place on myself, and that's why I call this simulated chip carving, because everything has a full V cut at the bottom. So if we go over to the 3D view over here, and that's the preview right now, I'm going to click on this lower left button up here. That'll enter back into this preview window that many of you see when you first, that pops up when you do your toolpath. And this window is called the preview toolpath window. And that's what this is used for. It shows you exactly where your tool bit is going to cut. And it's a great page, or it's a great thing to look at to make sure that your design is turning out the way you want it. Because if you don't see what you want here, then you need to go back and make some adjustments. But I'm going to go ahead and reset this. And just want to talk about one thing here. If I were to go in and let's just create a large, well, actually, let's do this. Let's create a large rectangle right up here. And then I'm going to just use this V-carve toolpath right here, open that up. And if I were just to take a basic V-carve toolpath, select that large rectangle, what happens, you'll notice, is it's giving me a warning that I'm going to cut through. So it's going to cut to a maximum depth here of 0.923. Our material is only 0.75. If I click OK on that, if we go over the preview and we look underneath the bottom here, we can actually see the toolpath coming through the bottom. And if I run the preview selected toolpath, it actually cuts through like that. So if you're new to V-carve, that is one thing that can occur if you have large areas that you're cutting. And although we're not using this option for this cutting board, you can solve that by using this flat depth up here at the top. Now, go back here 1 second. I'm clicking pretty quick here. I want to show you a couple things. So the toolpath that I just created is here at the bottom. And one of the things that I want to recommend is that once you create a toolpath for this, let's say the square or some other object, just keep editing the same toolpath as opposed to creating a new one. Every so often I see people that they go in and they believe that they have to click up here and they end up with a whole list of extra V-carve toolpaths. all you really need to do is highlight the toolpath you wish to edit or make changes to, and you can either, with the left mouse button, double click on that little icon right there, which is the easiest way to do it, or if you hit this pencil up here, see where it says Edit Toolpath? If I click on that or double click on the icon down here, it'll reopen that toolpath into the edit window for that toolpath. So that's just a quick way to get back into the toolpath. Now, since we're cutting through on this one, we're going to add what's called a flat depth. So let's make this, limit this depth to half the thickness of the material. And this is strictly a design element. You obviously don't want it to cut through, but whatever depth you add here depends on what kind of final look you want. So in this case, we're going to hit calculate. And now I'll reset this. And that, now you can see how we have a flat depth. Now, there's a lot more to be said about that setup, but that doesn't really directly apply to our project. So I'm not going to go any further on that. And let's reset that, except to say that all of these triangles and shapes are of such a size that I do not need to use the flat depth. It's simply not going to cut through. And as I said earlier, that's just a little parameter that I place on myself when I do these kinds of designs. You certainly could, but just from a design standpoint, I like the look of this full triangular depth inside. Okay, so with that, I'm going to split the screens here so we see both of them. There we are. And I'll right click on this one I created. I don't need that, so I can click on delete this, and that'll delete just that one toolpath. Okay, so I have two V-carving toolpaths set. Well, I have three V-bits here. You can see the little icon. But the first one, if I click on this, this is for that star shape right there. So I'll come back and revisit that in a minute. I just want to recalculate it since I think it got disassociated. And then we're going to take and click on this one down here. Okay, so let's do something here. Okay, so pausing for a second here. I have these already created. So I want to make sure that this toolpath is associated with the correct tools or the correct vectors over here. Now, the reason I'm doing that is because if I click on this check mark right here, notice how it makes it visible. Okay, and so it's telling me where it's going to cut. But when you use VCarve for a while, you begin to learn that that image on the left side over here, those lines should be glowing right now, and they're not. Because when you select the toolpath right here, it shows you the associated tool vectors. But something got disassociated here. I'll show you an example. So if I go up to this one, notice how when I highlight it on the right, these turn pink on the left. That's because it's telling me which ones are associated with it. So it's always important to make sure, even though I see information here, what can happen is that if you create a design, you create a toolpath, and then you go back and make some changes, which I've been working on this one today, and by making those changes, this toolpath still exists, but the vectors that it existed, that it was associated with, have disappeared. So even though it looks like I have a toolpath, which I do, it's not going to cut the same vectors as what I have on the left here. Notice what happens if I go right click and ask it to recalculate. It's giving me an error. It says it's going to cut through the material. Well, let's see what happens. Whatever errors occurred, And basically, there's no vectors associated with it. So I'm going to double click on it, select all of those vectors with that little rectangle going from the left to the right, calculate it. And I can even preview it. That looks good. Now again, let's revisit what I just showed you. If I go in and highlight that on the right side, notice how they turn pink on the left. If I click on the handle one up here, that one turns pink. So this is another one to verify that if you've made changes that your toolpath is associated with it. If it's not, then you have to make sure to go back and recalculate it and reassociate it with the selected vectors. So let's try the cutout, see if that's associated. So again, it's not showing up pink over here, so somehow it got disassociated with it. So I'll open it up, go over, select that vector, recalculate it. This is telling you how to cut through a little bit. That's okay because that's the outside. And it says to add tabs. It's telling me I need to go back and add tabs. So let's do that as well. Okay, now it calculated it. It gave me a warning that there weren't any tabs. So I'm going to preview this to see what it looks like. And we can see there that it cut through all the way around without tabs. And the reason for that was because it lost those tabs from the previous setting. The other thing, so let's go back into it. On the right side here is edit tabs. Now, if you haven't played around much with tabs, there's a couple things to think about here. What is the length, which you might also think of the width of it. That's like the bridge length. And then the thickness, of course, is how thick it is. And there's two types of tabs listed here. There's what I call the standard tab. It's kind of like a brick. And then you've got a 3D tab, which is more like a speed bump. The advantage of the 3D tab is that the router bit simply slows down and kind of like going over a speed bump. It just goes up and down. It keeps on going. Where with the standard tab or the brick-shaped tab, it actually has to really come to a stop, go straight up, go over, stop, and go straight down again. So it can potentially, on critical projects, it can leave a little bit more of a mark and also take a little bit more time. The time isn't significant, but depending on what material you're using and which router bit you're using, it sometimes will leave more of a mark on the edge. So I tend to use 3D tabs most of the time. The only thing you have to be aware of the 3D tab, it's really half as much material holding it on. But on a project this size, 0.75 in the length and an 1/8 inch thick, that for most materials is going to be quite enough. So let's go ahead and add some tabs onto this. Now you want to, there's lots of settings in here for adding automatic tabs, but the other way to do it is simply go over to your project and click on it like that, and it'll left click, it'll make a tab. If I go over it and left click again, I can slide that tab around to a new location, or if I click it again, I can delete it. So it's pretty simple with a couple of clicks to put them where you want them. Now, a couple of things to think about when adding tabs. For one thing, you know, this inside curve here isn't too bad, but sometimes if you put tabs on an inside curve, it can get hard to clean them up in there. So usually putting tabs on the outside of a curve is a better location. And then the other place I might put a couple of tabs would be down at the bottom here, something like that. If this is a particularly large cutting board or shape, I might decide to put one here and maybe one at the top and get rid of these two. Experience will show you how many tabs you need. It's surprising. It doesn't take a dozen tabs to hold this in place. In fact, these 5 should be quite adequate for this project. One other thing to consider when adding tabs is the wood grade. Okay, so in this project, the wood grade is going vertical. So when these tabs are cut, the wood grade is going to be going vertical through that tab. So that's going to make a nice strong tab. If you put tabs on the sides of your project like this, where the wood grade is really running in this the length of the tab, there is the possibility, I've had this happen in a couple of projects, where that material potentially could crack there and the project could come loose. So sometimes if I put it on the side, it may come a little stronger. The other issue is that sometimes these tabs, when you take the project out, it can chip out and actually chip into your project. I mean, both tabs can do that. So when you take them out using something like a Japanese saw or a little back saw, or even the band saw works well, and then sand them down. Some projects out of MDF, you can get by with a chisel or a utility knife. You'll come up with some solution there, but you just want to be careful when you remove them not to chip out your project. So we're going to go ahead and leave that with those 5 tabs, close over in this side, and then I'm going to recalculate that. Back over to the right side, reset the preview, preview that toolpath, and there we can see our tabs. The other thing this preview does for you is that, like I said, it shows you what, how it's going to carve. And so if I had that tab set too close to the corner, that tab actually might wrap around the corner. And that may or may not be a problem for a particular project. But this looks like a pretty good setup for the cutting board. The hole at the top, we can see right there. Again, let's open that up to make sure it's associated with a vector. It's optional here, but we can see my original toolpath was up there, a little bit different location. So I'm going to select that vector. And let's preview that. Now let's pause for a minute, talk a little bit about this handle hole. I'm using for this, if I double click it open, I'm using a profile toolpath. The reason I like to do that is that you certainly could use the drilling toolpath, but by using the profile toolpath, this diameter of this circle could be anything up to, like, say, even a ½ inch. And as long as I'm cutting on the inside of it, it's going to cut out that diameter. So for my practices, I typically will use the profile toolpath to cut it out, as opposed to drilling toolpath, although the drilling toolpath, if it's the exact ½ inch that you want, that can work as well if you've ever used the drilling toolpath. Otherwise, the profile toolpath is the toolpath of choice for cutting or for routing holes out as opposed to drilling them. And so we'll just calculate that out. Okay, with that, we're gonna come back and take a look at the end chamfer a little bit later, but I want to take and look at a couple bits of information on the V carving. Now, V carving, as I've said before, it's a great toolpath because it creates decorative shapes very quickly, very easily. Sometimes people are tempted to use a, like, let's say they're doing a letter. Although let me think about this a minute. What is a good shape for this? Well, yeah, let me just show this part here. If I take a square, or rather a line, we talked about this last time, is that the difference between using the profile toolpath or the pocket toolpath and the V-carve toolpath, one of them between the profile and the pocket, is that a profile toolpath, you can think of that much like a table saw or a bandsaw. You're going to follow the line, just like we did around the outside of this project. We're going to go around the outside of it, the inside of it, or on it. And so for this line here, we could actually just cut right on the line, and it would cut a slot, and that would work fine. You can actually use a V-bit for this. And let's take this one right here. But when you use a V-bit with the profile toolpath, you have to set the depth because it doesn't do it automatically like it does with the V-carve toolpath. And so when you start, if you're starting out, you're going to use these toolpaths, come to understand the difference between these two toolpaths in particular. The V-carve toolpath is a decorative carving toolpath, specifically made for doing that decorative carving, where the profile toolpath, the best way to think about that is much more like a handheld router or like a bandsaw or a table saw where you're following a line. So I've got a 90-degree bit set up here. And if I leave that cutting depth, the same depth we had for cutting through this material, and we're going to cut on the line, notice what happens. It says we're going to cut through. And we can see all the tool paths there. If I preview it, there it cut through. We can see the V at the bottom. We can see the shoulder. So it really plunged down, just like if you were using a handheld router. It just goes straight down to whatever depth you set. And then the other part of it is that if we open it back up and we just put a shallow depth on it, let's put a 0.8 of an inch. And let's reset. So there, that makes sense, right? It's a V-bit. Notice that we've got rounded ends. So if any of you have ever seen or tried to make signs with a handheld router, you'll often see that when you come to the end, you'll get that rounded end like that. And that's because it's following that line at a consistent depth the whole way. It plunges down and then it lifts itself out. So again, the big difference between that and a V-carve toolpath is that the V-carve toolpath, call it a smart toolpath, is cutting inside of this area, and it uses the tip of the bit to cut up in these corners to leave nice sharp corners. There are times when you may want to use the profile toolpath for carving some things, but just realize that it gives you a different look and you control it in a different fashion. So with that said, then when we're setting up our V-carve toolpath and designing it, we have those different things in mind. Now I want to show you a couple of special things about the V-carve toolpath and V-carve bits. Cool. There we go. One of the first things is to realize that a 60-degree bit and 90-degree bit, these two will cut to different depths, even though the top of the cut remains the same width. So if we had a pair of lines that were a ½ inch apart, and we're looking at the edge of the board right now, but if these two lines were going across the top of the board, what the 60-degree bit or any V-bit, it goes between those two lines until it goes to the very edge of those lines for both the 90 and the 60. Notice that the 60, however, cuts deeper, even though the top of it is the same size as the 90-degree. And that's valuable to know because if, let's say, for instance, you are using a 60 and you're in thin material or something and it keeps cutting through your material, you can increase to a 90 and it'll cut shallower. In fact, sign makers who make large signs that go on the sides of buildings or like a realtor side or a welcome side or a business side, they will sometimes use a V-bit with like 100 to 150 degree angle on that. So it's a very shallow V. So it doesn't cut so deep, but it still gives you that angular cut because, of course, their signs are so large. The opposite is true also. When I do small lettering, say 1/4 inch tall lettering, 3/8 inch tall lettering, I'll often use a 60 degree bit because it goes a bit deeper than the 90, even though the top of the letter is the same size. Because it's going deeper, it makes it look darker. If I'm finishing it, there's more space for the finish to go into. So for small letters, things that have lots of little tiny details, I'll often switch to a 60 degree bit. But for larger lettering, a couple inches tall or whatever, inch tall, as well as this cutting board, I'm using a 90 degree bit because I don't want it to go so deep. So the angle of the bit does not affect the finish width of the cut at the top of the material, but it does affect the depth of it. And you can use this to your advantage in lots of ways, like I said. For small detailed carvings, go to a 60 or even I've even used a 30 on some projects. But a 60 is a pretty common one, and a 90 is kind of the workhorse for general V carving. Any questions up to this point? Got some more stuff to go into, but I thought I'd take a little break here.
I've got a question.
Yeah.
You said a drill toolpath. Which one is the drill toolpath?
So it's
okay.
Right there.
Okay. All right.
That's fine. Nope, you can check it out. Here's a little tip I want to pass on to everybody. When I open this up, and this is true of any window you're in, see that question mark up there? If you take and click on that question mark, it opens up the V-Carve user guide, and it usually opens up, in this case it didn't, but it'll often open up to information specific to that project or to that tool. So I was expecting it to open up to the drilling toolpath information. It didn't, but if you drill down on the left side here, you'll eventually find that information, and it gives you details on how that works. So if you're going through VCarve and you have a question about something, you can always click on that question mark to open up the user manual for VCarve. It's very large. It's a lot of information there, but it's a good place to get some quick information on it. Okay.
As long as you brought that up, maybe you can say something about peck drilling.
Say it again.
Well, when you opened that up, you had peck drilling highlighted, which is basically the ability to pull the chips out so you're not drilling in one stroke.
Very good point. Yeah. It's much like when you're using a drill press. You go down, you go up, you go down, you go up. And so you have two options here. Retract above the cutting start depth. That's typically the one that I would use. That way it'll bring it out of the material. Retract above the height of the previous pass only brings it up, in this case, maybe 1/10 of an inch each time. So that's a good way, especially if you're using any kind of bit. You want to get those chips up and out of there just like a drill bit. So I most always use that. Good tip. Anything else from anybody?
There we go. When I made some coasters and I stacked some wood together and was using a dowel rod, the guy that showed me how to do that increased the size of the, we were doing the that first, the one where you cut out I don't know what they call these things, but
We-
I was using that one, and he made it just a little bit larger so that when you put the dowel rod in there, it wouldn't go in so hard where you had to pound on it. Do you do that, or is that a suggestion?
Absolutely. So right
Okay.
here, so let's look at this. So first off, if I take that circle right there, and let's see how big this circle is. So the circle is 0.26. So what are the first things? If you're going to create a hole that's going to use a 1/4-inch bit, and you're not using the drilling toolpath, but using this profile toolpath right here, let's open this one up. This profile toolpath. Sometimes if your circle is 0.25 and you're using a 0.25 drill bit, or rather a router bit, sometimes V-carve doesn't like that and it won't let it go down in the hole. So I usually make my 1/4-inch hole, since it's not a critical size in this case, just slightly larger. That's one thought. Now let's say if I were to move this circle, copy it over here, and let's say this circle was actually that big, my router bit is going to be going around on the inside, kind of like this, cutting all that out. Now let's see what size that is. Well, let's say that was for a 1/2-inch dowel, something like that. And of course, we know that 1/2-inch dowels are perfectly 1/2-inch every time you buy them, right? So that's the problem. So I like to design, in theory, with a 1/2-inch dowel hole, if that's what I'm going to cut it at. But over here on the profile side, well, first of all, let's just take and cut on the inside. And let me calculate this. And we're going to take a look at the preview. Now, that's my extra vector. I don't need that. This line right here is showing the middle of the router bit spinning around inside that hole. And up at the top up here, here's a little preview. This is called the 2D view, which is what we're looking at. If I want to look at the solid preview, I click on this and it turns, kind of a blue-purple. That shows me where the router bit is cutting. As you can see, it's cutting right up to the edge. Now, if I want to overcut that a little bit, I can do that by going inside my toolpath right here. I'll go inside what's called the handle hole toolpath I'm using. And right here, allowance offset. That's the area you want to add something to. Now, we're on the inside. So if I add a positive number, it's going to go further to the inside. So let's say my dowel is undersized by a small amount. Let's type in 10,000ths of an inch there, and we're going to undersize this hole because we're going to move that allowance is going to continue going towards the inside. Notice what happened over here on the right. Notice now how my preview of the blue area, it set that inside that by that 0.01 on each side. If I want to enlarge this a little bit, I still need to cut on the inside of the hole, but I put a negative, which will actually make it go larger. I know it sounds kind of odd, but that's the way it works. Now when I click on this, now you can see how it went a little bit larger. Left a little bit in the middle. Usually that little bit doesn't matter, but that oversized it a little bit. Just remember that it's adding it to both sides. So if you're making your dowel and your hole, you're going to want to add the correct amount accordingly. Otherwise, it'll end up being too big or too small. So that's one way that you can make your dowels fit. And yeah, this is a great tip. I do this a lot. I teach it in my other classes. We have a project actually where they have to fit like 6 different dowels and they have to match it. So that's a great way to custom size a hole. And then it allows you to do your layout with a standard size shape of 0.5. Now, when I said earlier about this one being 0.26, we could have done the same there. I could have made it exactly 0.25 and then used that allowance offset that we just showed you there, and it would have done the same kind of thing. And then it would have fit in that area. Like, let's try that for a minute. I'm going to go in and change that to exactly 0.25. Open up my handle hole toolpath, select that vector instead. Off the right over here, I'm going to remove the allowance and click calculate. Okay, now it says it's going to go in. And notice here, error, no toolpath generated for current parameters. Check tool can fit into check tool can fit into selected vectors at machine depth. So this is the error that's telling you that no toolpath was created because it can't fit inside that hole. So we've got a 1/4 inch router bit going inside a 1/4 inch hole and it won't fit. So we'll go ahead back up here to that allowance. We want to make the hole a little bigger, so we actually have to add a negative allowance. So we'll add, actually, we'll just add a paper thickness all around, because when we add those, when we double those, that'll be 0.01, which will give us that 0.26 when we're done. And bingo, it went in that time, and there you can see a little extra cut. So on the right side over here, something that you'll notice when sometimes you recalculate a toolpath, notice how I had this toolpath right up here with this group 1, but because I changed some of the parameters and some of the vectors, it recreated itself where it moved it down here to this other group. So just keep an eye on that. Occasionally those toolpaths will disassociate from their current location, and they will reappear down below. So if the order is important, you always want to verify that. But let's go back in. I'll take that. I'll drag it back up where it was, right there. I'm going to open it up, go back and select the original hole. I don't need the offset. Calculate that out. And we're back where we were to start with. Okay, there's some other VCarve stuff I want to take a look at. So let's open up this information here. Now, this is going to get a little technical, but what I want to focus on is that these two pictures right here. Sometimes you do V-carving, and this is a bit of an exaggeration. I did this deliberately. But sometimes you see these lines going around the edge, and they can be really hard to sand out, and they can be really annoying. There's a couple reasons for this, and tonight I'm going to focus on one main reason, which has to do with the angle of the bit. Now, just like dowels being exactly a 1/2 inch, which we know they're not, router bits are spec'd at 90 degrees, but sometimes they're not exactly 90 degrees. Now, this has become less of an issue than it was 10 or 15 years ago or 20 years ago when I started out. Back then, V-bits were basically for putting a V-groove in a board or putting a V-groove in the edge of a board, and nobody really cared if it was exactly 90 degrees. They just wanted a bevel. But since the advent of CNCs, suddenly the CNC will reveal if something isn't accurate. And so this is probably the most common problem you'll see, maybe not this, likely not this strong, but you might see something more subtle. Let's see if I've got it here. There we can see some small lines. That's pretty acceptable, but you can see a few small lines right there. Let's take a look right here. Now, first of all, right here in the middle, This is a 90-degree V-bit, and it's exactly 90 degrees. And what V-carve does is V-carve, again, it looks for the width of the lines you're cutting between, but the V-carve will take the tip of the V-bit follows a theoretical 90 degree on both sides like this, okay? And so because the edge of that router bit matches that exact 90 degree profile, and the V-carve, the program, the G code tells it to move down and move over, move down and move over at this precise amount. And so you get these nice, in theory, you get nice smooth edges to it. However, if your bit is less than 90 degrees, and that could be 1 degree or 2 degrees, you will end up, notice here, when this bit goes up and down in that 90 incline right there, that because the tip of this bit is the middle of your router and the bottom is what you zeroed out on the top of your material. So V-carve is then said, okay, I'm going to take the tip of that bit, I'm going to go down a 90 degree or 45 degree incline right here, and then the rest of the bit will just follow along and do the cutting. But notice how it's actually leaving material. And so with each pass, so it cuts a pass there, I'll make a duplicate here, cut the pass there. So there you can see how it's leaving material here and here and here. And that's what you're seeing in this drawing below. So if I put my thumbnail down here, these are little ledges that if I slide my fingernail down, I can feel it on the top side. And like I said, this is, I set this up to make it quite prominent, but you may not see it quite this strong, but it might be some, I've seen some that are almost this bad. The other thing you'll notice is that, notice how these corners are kind of curved out. And that's the other thing that happens with this, when the router bit is, you expect it 90, you set up a 90-degree toolpath, but the bit itself is under 90. So that's a telltale sign. Okay, let's flip to the other side of it. If you have a bit that's over 90 degrees by a degree or 2 or 3, it's going to remove extra material at the top edge and not the bottom edge. So in that case, you'll get a fairly smooth cut. Notice here, we got a fairly smooth cut, but this shoulder right here, because it undercuts, when it goes down towards the bottom, it leaves these ridges. And so these ridges are on the bottom side. This is somewhat less common, but I have seen it. And it's rarely this obvious. But the other thing you notice at these ends, it starts to give you these weird curves and shapes on the ends because the angle of the bit isn't matching the angle that the toolpath was set up for. So there we can see a top-down view. And I have seen V-bits that were off. Again, this is exaggerated, but you can see a little bit of, you can see that in some of, sometimes. Most people, including myself, are mostly we're concerned about this ribbing on the edges, which can occur right here. Now, this was the result that I got with my 90-degree bit. And I got a little bit of a ledge right there. And that's that top edge of the router bit. So what that was telling me is that my bit is slightly over 90 degrees. So to solve it, I took it up to 92 degrees, which gave me these results, which are pretty good. I can see a little bit in there, but having done a lot of this in the past, once I finish this and a little bit of sanding on it, it's probably, or painting, it's probably not going to be visible. Also got some nice sharp corners right here. These are a little rounded. I think the reason for that is this side of the material was a little thicker. I didn't double check how level it was. So how do you determine all this? Well, I've got another file here I'm going to bring up to show you. But the main thing to start with, I want to point, if you see results like this, which are the most common, the way to solve this, so here's a test file that I created, and I will include this with my email tomorrow. Now, again, this is getting a little technical for those of you who just started out, but for those of you who have been doing V carving for a while, and if you're experiencing some of this with your router bit, I can, you could go this route to clean it up and try and get better results. It's also a great exercise just to understand the dynamics of how router bits work. And I'll show you a picture in a little bit. I use on a Mana 90-degree insert bit. It's probably my favorite bit because it has such a sharp edge to it. So right here is the router bit that I like to use for V carving. I also use a 60-degree engraving bit, which in this case, it's an Onsrud for fine, tiny carving. And I love it for that. It has a really sharp edge to it, and it produces really great results. But for general workhorse 90-degree V cutting, I use this 90-degree bit. Let's see what we can find here. It's available on Amazon or Tools today. Let's see what information, if this link works. There we go. Okay, so they're selling it for about $35 Tools today. And what's interesting about it is you can see the insert. See if they show. So that insert has four points to it, and it can be rotated when the one point gets dull. And it cuts only on one edge. The other edge is a trailing edge. It doesn't cut on the backside, it just cuts on the one edge. So it's a single flute, which gives you a really good chip load. It's a very sharp edge because it's a very high quality carbide. The only caveat I have on this, when I've changed these, sometimes rotating this bit can be a little tricky to get it precisely centered again. A couple of bits I have about 6 of these that I rotate between when I do my classes. And a couple of them are a little hard to set. I had one today I just tested on. I rotated the angle and it came out perfect. Others I have to tweak it a little bit. We'll take a look more at fine tuning some of these in the future. But if you're looking for a really nice workhorse of a bit, this is great. Now the price, as you can see, this is almost the price of a really good quality V bit anyway. But these inserts are less than $10 a piece. So they're like a couple of bucks per tip. So once you get this bit, you're carving for just a couple of dollars a tip, and being a very high quality carbide, they last a long time. So I really enjoy them. Now, how do you use this? So if you have a bit that's not quite cutting perfect or leaving ridges like that, you could use my setup here. What I've done is that inside, these are all V-carve tool paths. Each one is associated. Let's deselect all of them, turn on the solid view. So that one's the top one. And you can see they just click all the way down, just like that. So those are associated on the left side, and then I've got the 90 to 100 on the other side. So you could select whichever of these you wanted to cut. If you thought you were only, your bit was oversized in the angle, well, you only need to cut the one size. And if you think it's really close, you only need to cut a couple of these to do your test. So you don't need to use them all to do a test, just use the ones that work. But setting this up is a little tedious because let me open up this 80-degree one. Notice that it says this is an Amanda 90. This is set at 80 degrees. I go into edit here, and I'm going to change the parameters just for this single tool path. And notice I changed the angle to 80. So even though the name of the tool path still says 90, V-carve is going to think, because that's the bit I'm actually using is my 90-degree Amana V bit. But V-carve is going to think it's an 80-degree bit, so the geometry of the G code, it's going to move it accordingly. So I have done that then with each one of these. I've gone in and customized the actual degree setting. So what you do, if you have a bit that's not cutting correctly, select a range, take that bit, run a series of these tool paths, and then you'll be able to pick the one that has the best performance and then use that setting. Then what you can do is go into your tool database, locate your 90-degree bit like this, and let's say your 90-degree V-bit up here is actually operates best at, say, 92 degrees. You can put that in there, save it. So you can save that. And then every time you use this bit, that'll already be in there matched with your bit that you have in that angle. You don't have to retest it then. That's how you could set that up for long-term use. Okay, at this point, I'm going to take a look at the.
Randy, there are questions that come up on the chat.
That's what I'm looking at right now. Yep. Thank you. And Tim here says that most end mills do not have cutting edges on the bottom for plunge cutting. Yeah, so that's a really good point too, is to think about when we talk about straight bits in general. Bring over our handy Google search here. End mills, technically, the term end mill, this is probably a pretty good example there. You can see how the tip of that has cutting edges on the edge. It's like a drill bit, okay? But a simple straight bit, there, that Freud right here, that's a good example of what is a straight bit, but it is not an end mill. Same with this 1/4 inch right here. It is not an end mill. This one, however, is an end mill, and most spirals are end mills in that sense. So when you're setting it up, again, these are not end mills. Notice there's actually a gap in the middle. So these will not drill. And that's another reason why when you're setting up a profile toolpath or using a straight bit like this for any operation, you want to make sure and add a ramp. And that lets it down into the material gently. So, but these will not work with the end or with the drilling toolpath. Okay, Tim has another good tip here also. He's talking about if you think the V-bit is not lined up, is to lower that tip down to the top of your material and spin it around. And if it's leaving a dot, then something is out of alignment and needs to be readjusted. This also applies to, if you end up having a cheaper V-bit that you picked up someplace, sometimes those can run out. Your router bit can actually, your router collet can sometimes have run out, which will also cause it. Another option that could occur, which is a little more serious, but is potentially solvable, is let's say I'm going to take this, let's rotate this, exaggerate. If your spindle is not plumb to the table, it's not going to spin on center either. So tramming the router, which is information out there, we'll go over that one of these meetings on how to true the router to make sure it's perpendicular. That's another thing that could cause it. Another thing is on some of the lighter duty machines, you can end up with some flex if you're too aggressive with the carving or really hard wood, or if the bit is kind of dull, it can actually push that bit away from the carving path, and that can also create some of those ribs that we saw earlier, those lines. So it can be multiple reasons, and so it's always worth kind of working through each of these to try and boil it down and figure out where it's at.
Oh, Randy?
Yeah.
Okay, it's the other way around. You said if it leaves a dot, it's out of tram. It's actually the other way around. If it leaves a circle, it's not aligned. Just
You are
wanted to
correct. When I
clarify.
said dot, I meant circle, but you are correct. If it's not leaving a right, if it's leaving anything but a little small spot, yeah, you
Absolutely.
are on alignment. That is correct. Okay, the last thing I want to look at tonight within the toolpaths is the chamfering toolpath. So the chamfering toolpath is a new toolpath that was added in VCarve in the last version or two. You could do the same process with the VCarve toolpath or the profile toolpath, but the chamfering toolpath, if I open it up here, automates it. And again, let's make sure to associate with the new vectors. And so there, it looks like a VCarve toolpath, right? But when we cut this out, it's actually just putting it on the edge of the board. And it's really a nice toolpath for softening the edges of the board. Now, here's a couple things to think about. If you've not used this before, I'm going to open it up here. You can start out thinking of it much like you would a profile toolpath. It's going to follow that line all the way around. And then we're going to use the same 90-degree V-bit we use for everything else, just to keep things simple. And then you want to think about how wide you want your chamfer. And with a 90-degree, what's convenient about that is the width and the depth will equal the same. And the value of that, or rather the simplicity of that, is because of the 90 or the 45, it ends up being the same. Now let's look at using this one here. Oops. Take and move this over. So there, it's going to cut the same width and the depth. Open this up again. That width, whatever you pick, so if you change this width, if I change this to 0.25, notice how the cutting depth also changes, so it'll automatically adjust that in both directions. The other thing is that this overcut is one of them that a lot of people say, what is the overcut? Well, what the overcut does is that the overcut maintains, maintains this width and that depth cut, but it takes the router bit and it cuts deeper, but not any wider, or it doesn't change the profile of the chamfer. The advantage of this is that sometimes if your material is a little bit off size, you could end up with a little bit, you can see if this were, let's say it was like that, my material is a little oversized, I'll end up with that little ridge right there. So by doing it like this, it overcuts it and gives you a nice clean edge. The other thing that's nice about this is if you have a V-bit that has a chip tip on it, you don't have to worry about the tip. You can still make use of the edge. And I don't have a couple of those, so they work on handy as chamfer bits. So that's the one thing to consider as far as when you set it up. Now in this setting, I did not add any overcut because we're actually cutting to the very line that we cut out with the straight bit. So that line right here should be essentially perfect. And so I didn't add any overcut to this. If I was going to the outside of this rectangle, I probably would, to make sure that it was giving me a nice clean bevel. Now, if you change out from a 90 to a 60, then you're going to get different values here on the widths. The other thing to look at that is often confusing is right here, is on the inside or outside. Well, just think of it practically. We're going to go to the outside, and that's where our line is, but we're going to be sloping we're going to be going upward from that line into our material. So that's what the outside is. And if you haven't used this and want to understand it more, I'm not going to give a lot of demo on it right now tonight, but I would encourage you to go out and just start playing around with it and see how it works. And you'll see which ones work well. This is one of the common ones. Let's take that. And those settings look good. We saw it earlier. If I were to click go down instead, let's reset this. Let's do the two visibles. Look at that, no chamfer at all. That's because the chamfer, we said slope downward, so that pink line in the illustration here, which represents our vector, went from here out. So if we were to preview this, notice where it's cutting outside that line. So that V bit is cutting right there down the middle of that line like that. So that's downward on the outside. So again, depending on whether what your shape is, will depend on which of these you select. But give it a try. It's a great way to add little profiles to the outside of your projects. Any other questions from anybody?
Randy, when you do the profile cut, you do ramps and leads for your profile cut?
So yes, I almost always add a ramp, and recommended length is anywhere from, depending on how deep you're cutting, but like a 1/4 inch bit, I usually do maybe about a 1 inch ramp, and a ramp eases it into the material. I use a smooth ramp. I almost exclusively use a smooth ramp for almost all my work. Leads, for those of you who are not familiar with leads, so think of a ramp like a boat ramp going into your material. You can think of a lead as a entrance ramp onto a highway, because you're going to come in from the side. So if I add a lead to this, and it says I'm going to use let's use a curved lead. And let's see what happens when let's select our line, calculate that. And if we go back over here, there you can see the lead coming in. The reason the lead is right there is if I right click and hit node edit, that's the start point. That green dot means typically that's where the router bit is going to start. So let's say I wanted to change this up a little bit. I could put it on the side right here. I could right click, insert a point, go back over it again, right click, and make that the start point. Now that's my start point. Now let's find our cutting board cutout. Let's right click. Let's recalculate. Okay, something didn't click. Let's try it again. Let's see here. Oh, let's add the lead back in. Oh, and notice also how some tabs moved around also. So we got to edit. I'm going to remove all the tabs for now for this exercise. Okay, and let's try it again. Okay, so this is a good example of why when you hear me say about moving, checking, let's see, what do I got going on here? Aha. All right. I had a couple of the toolpaths highlighted. Again, if you don't see what you want to see on here, pause for a little bit and figure out what's going on. Don't go to your machine. Okay, so now I got a straight lead going in here. I want that to be a curved. So I'm going to open it back up, go back into the leads window here. Let's make a curve on that. Let's try it this time. And there we see a lead in. Now, why use a lead in? The value of a lead in is that whenever you go straight into your work, let's reset this. So there's the lead in. if you don't use a lead in, and you don't always have to use one, but it may improve your edge quality, because without a lead, even with a ramp, and a ramp helps, but when that router bit enters the material, it's likely going to leave a little bit of a mark. A dwell mark is what it's sometimes called, or a witness mark along the edge of the board. And a lead in eases itself in. Like I said, thinking of it kind of like an entrance ramp to a freeway, it eases it in and it leaves less of a starting mark in some woods, especially when the edge quality is critical, if you're not going to go back and sand it or plane it. Now, in this case, I have what's called a lead in. I'm going to change that lead in. Well, that's okay where it's at. I'm going to go in, however, and update it. You can also add a lead out, so it'll go both directions. And this thing called an overcut distance, think of that as the space between the two leads. So let's add a 1/2 inch overcut. And I'm going to increase the radius on this to, or decrease it to 1 inch. Calculate it this time. Reset, preview, and there you can see it's cutting in and out in the same toolpath.
Can you do both a lead in, lead out, and ramp?
Yes, you can. So I'll open it back up. I've got ramps added here, and then see what it says here? Ramp on lead in. So when you ramp on the lead in, you lose your distance settings because it's going to take the length of the lead and it's going to ramp during the lead in. So we've got a 1 inch radius, lead length is a 1/2 inch. Let's increase that to 1 inch, see if it'll take it. There we go. And there you can see a larger lead in. Now, go back here. There, you can see it. So it's only going to ramp on the lead in. That's all that's critical, because on the lead out, it's going to come over here and just pop straight up. But again, the reason for adding this is if you have a project where the edge quality, where the bit is going in and coming out, is leaving marks and you're trying to avoid it, that's a great way to, that's one strategy to use.
What about on circles, inside circles? Can you do a lead in and lead out on those? Because it makes the circle much better.
Sure, let's add a new layer here. Draw a circle right here. Take this cutting board. Okay, so I'm going to take that toolpath and I'm going to duplicate it. So I got a copy of it. I'm going to move that to the bottom. And let's rename it. Let's call that circle cutting. Okay, so I'm going to open that up. One more change here. I want to turn off that one. Double click on the circle cutting toolpath. Don't need that circle. Select that one. Okay, so let's cut on the inside. I believe you said you wanted. And we're going to ramp. We're going to lead. We're going to lead out.
No, that's perfect.
Yeah. And let's, okay, to avoid gouging. All right. So you may get this. It's saying that the lead in and lead out are going to collide or something. So not too bad. And if we wanted to increase that further or do some other shape, this might be a good one rather than a circular lead. Let's go with a straight lead and let's go a 45-degree angle on that. And let's use a lead length of 1.5 inches, just see how that looks. Well, there. So now actually, because this is kind of an acute attack angle right there, I would still probably for the circle, I would prefer to use the circular lead. And let's try this radius again and that length and see how that looks. Okay, to avoid gouging, one or more leads may have been reduced in length or completely removed. The ramp with the lead option was also selected. Therefore, no ramps will be created in the case where the lead-ins were not added. Okay. I think it's still producing an acceptable result, though. In fact, those light blue lines right here, these aqua lines, that is the ramping. So that is the lead-in. So that looks good. There you are. So that would improve the quality of the inside of that circle. Anybody else? Okay, then. Well, I tell you what, I'll package up some of the information from tonight, that one VCarve file, and then I'll also put a link and a copy of the file for the cutting board in the email. So you guys, if you don't have it, you can get it, and you'll have my email again. If you have any questions, drop me an email, and I'm glad to help you out. All right, guys, have a good night.
Thank
Do
you.
appreciate it.
Yep.
Thank you.
Thanks, Randy.
Okay.
Thanks.
Hopefully see you next week. Good night.
Yeah, thank you, Randy.